Welcome to Lesson 6 NS4, Least Common Multiple. So we're going to work on today how to find the least common multiple of two or more given numbers. So first things first, let's look at what is a least common multiple. Well, the least means the smallest. Common is something that two or more numbers have that is the same. And a multiple is a number that you get when you multiply two non-zero whole numbers. I want to emphasize here it has to be whole numbers and it has to be non-zero. Alright, so then from that we can determine that the least common multiple is the smallest, and I'm going to change the word, I'm going to change the word number to value. So the smallest value that two or more numbers can multiply to. So remember, multiples are what you get when you multiply. So the multiples of 5 are 5, 10, 15, 20, and so on. There's actually going to be an infinite number of them because you can multiply any number by any other number and any other whole number. And since there's an infinite number of whole numbers, that means there's going to be an infinite number of answers that you can get because there's just no way to multiply them all. Alright, so that's why we look for the least common multiple, because you could actually never find the largest. So how do I go about finding this least common multiple? I have two methods. One method is the listing method, and it's exactly what it sounds like. The listing method is actually going to have us listing out our numbers. So let's give it a shot. So to start, you're going to list the multiple of each of the multiples of each of the given numbers. My suggestion, and this is what I do, I always write out the first 5 multiples of each of the numbers. So for 6, I have 6 times 1 is 6, times 2 is 12, times 3 is 18, times 4 is 24, and times 5 is 30. Then the multiples of 4, 4 times 1 is 4. Notice the first multiple of every number is that number itself. 4 times 2 is 8, times 3 is 12, times 4 is 16, times 5 is 20. So now that I have that step done, now I look for the smallest one that they have in common, the smallest one that's the same. And in this case, the answer to that is 12. So the smallest one that they have in common is 12. So the LCM of 6 and 4 is 12. Let's go ahead and try this. So we have 4 and 9, 9 and 12, and then 4, 8, and 12. You have a couple options here. You can try these on your own and then come back and check your work. You can do 1 or 2 with me and then try it on your own. Either way, I would like you to at one point give these a shot on your own and then check to see how you did. Just a reminder, first list the multiples, then find the smallest one they have in common. So let's start with 4 and 9. So I'm going to list those first 5 multiples. So 4, 8, 12, 16, and 20. And then I have 9, 18, 27, 36, 45. Now notice my multiples of 9, they go up faster than the multiples of 4 because 4 is a smaller number. So I might have to add to my list of 4s before I have to add to my list of 9s. And here's what I mean by that. If we go through and look, 4 and 8 don't work. 9 is the next smallest and doesn't work. 12, 18, 16, 20, 27. But now my next smallest number here is 36 for 9. And I had to stop at 20. So I'm going to add on to my list until I get around 36. Because it doesn't make sense to keep adding on to the list of 9 when I'm not even to the 30s yet for the 4. So here I have 24, 28, 32, and 36. And look at that. It just so ended up that 36 is that least common multiple. So I would have added all these extra numbers to my list of 9 for no reason. So the LCM of 4 and 9 is 36. Okay, let's go ahead and try the next one. I'm going to change my ink color so that way we can see that we're working with a different number or a different problem here. So 9 and 12. So again, I have 9, 18, 27, 36, 45. And for 12, I have 12, 24, 36, 48, and 60. 9 doesn't work. 12, 18, 24, 27. But 36 does. So oddly enough, my first two answers actually have an LCM of 36. I'd like to say I planned it that way, but I won't lie to you. I did not plan it that way. Alright, so now we have three different numbers. And even though we have three different numbers, that doesn't change the process. I just have to list three different sets of multiples. So let's go ahead and give this a shot. So I have 4 times 2 is 8, times 3 is 12, times 4 is 16, times 5 is 20. Then I have 8. 8 times 1 is 8, times 2 is 16, times 3 is 24, times 4 is 32, times 5 is 40, and then I have 12. 12 times 1 is 12, times 2 is 24, times 3 is 36, times 4 is 48, and times 5 is 60. Well, I know for anything smaller than 12 isn't going to work. So I can cross out my 4s and my 8s. 12 doesn't work because it's not a part of the list for 8. So even though 4 and 12 have 12 in common, it won't work because it's not in the 8 list. Alright, 8 and 4 both have 16, but that won't work because it's not a part of the 12 list. 20 isn't a part of anybody's list except for 4. And now I'm out of numbers, so I'm going to go ahead and add my next one. So 4 times 6 is 24. And you'll notice here that it worked out nicely that that is actually the first number that they all three have in common. So my LCM of 8, 4, and 12 is 24. Now that we've used the listing method, we're going to take a look at our second method, which is the ladder method. So to use the ladder method, we're going to use division, and when we set up our work, it actually ends up being in the format that looks like a ladder, so that's why we call it the ladder method. Really technical names here. Alright, so in the ladder method, one of the things that is really important to take note of is that you can only do two numbers at a time. So only two numbers at a time. That is incredibly important. So here I have three numbers, so I have to do the first two numbers first, and then I'm going to take the answer that I get and use that with the third number. So let's go ahead and give this a shot. First and foremost, I'm going to write my numbers in an L-shaped box. Fairly simple, so I have 6 and 8. I write them in my box. Okay, if you want to, you can split the numbers up like this, but you don't have to. It's completely up to you. Some students get confused and think that that's a 1, so it's completely up to you. I'm going to take it off to try to prevent confusion. The next step is going to be to find any number that can divide both numbers inside the L, and we're going to write it on the outside. Now, here's the thing. We want any number that can divide both of them that isn't 1. Because if 1 is the only option that we can use, that means our process is done. So we're looking for numbers bigger than 1 that we can use. So in this case, 6 and 8 are both even, so we can use 2. After I've written it on the outside, I'm going to divide. So I'm going to divide each of the numbers inside the box by that number outside the box. So it's really like we're using long division to work towards some answers here. Because I would do the same thing if it were set up like this, right? The 2 is on the outside, the 6 is here, 2 goes into 6 3 times, right? Well, I'm doing that upside down. So sometimes that helps students remember that you're doing division in this process. So here I'm also going to write down, so we're doing 6 divided by 2 equals 3, so that's how we got the 3. And then 8 divided by 2 is 4, and then that's how we get the 4. Right, so then now step 4 is to repeat steps 2 and 3 until the only number we can divide by is 1. Right, and then once that last number that we can divide by is 1, we're going to pull out the last two numbers. All right, so actually, that is the case. I can't repeat at all because 3 and 4 only have a common factor of 1. So then I'm going to pull 3 and 4 out of the ladder. My last step is going to be to multiply the L. So I'm multiplying all the numbers on the outside. So if you look at this, all the numbers on the outside, when I circle them and it makes an L. So I call it multiplying the L. You'll notice here though, when I multiply, I leave out one of the numbers. What you should have noticed is that I left out the 1. The identity property of multiplication tells us that 1 times anything gives us that same number. So it's not going to affect our answer at all, so we're going to take that extra step out. We're just going to ignore the 1. So 2 times 3 is 6. Bring down the 4. 6 times 4 is 24. So right now I found the LCM of 6 and 8. So the LCM of 6 and 8 is 24. Now, because of the fact that I have this third number here that I have to work with, I'm going to take 24 and 16 and I'm going to put them into an L. I'm going to put them in a ladder. So 16 and then my answer, which was 24. And I'm going to repeat that process all over again. So I put them in the L-shaped box. They can both be divided by 2. 16 divided by 2 is 8. 24 divided by 2 is 12. Now, do I expect you to write out these division steps over here every single time? No. The reason I'm writing them out right now is so when you go back to your notes, you have something to reference that helps you remember, oh yeah, that's how I got those next set of numbers. That's how I got 8 and 12. So now 8 and 12. Yes, 8 and 12 are both divisible by 2, but I also noticed it's also divisible by 4. You can use 4. So let's go ahead and use 4. 8 divided by 4 is 2. And 12 divided by 4 is 3. So I get 2 and I get 3. The common factor of 2 and 3 is 1, which means I can pull those numbers out, and then I am going to multiply the L. Really exaggerate the L there. So let's go ahead and write this out. I have 2 times 4 times 2 times 3. Now, I'm going to do this way. I have 8. So 2 times 4 is 8. Then I can multiply by 2 and I can multiply by 3. If I do 8 times 2, I get 16. Now, I know 16 times 3 because I've done this for quite some time, but 16 times 3 might not be a multiplication problem that we can do quickly off the top of our heads. But I could do 2 times 3 and get 6 and then bring down the 8. Because 8 times 6 should be a multiplication problem we know and get 48. Okay, so the LCM of these three numbers is 48. I want to emphasize the only reason that I was able to do 2 times 3 before doing 8 times 2 is because of the commutative property. Since we were doing all multiplication, you can do the multiplication in any order and you're still going to get the same answer. You cannot do that if you're working with subtraction and division. All right, so let's go ahead and give this a shot. Okay, you can try it on your own and come back and check your work. You can do one with me and then come back and check your work on the next one. It's up to you. So just a reminder, write them in an L-shaped box. Find a number that can divide and write it on the outside. Divide the numbers and write your answers below. Repeat steps 2 and 3. And then multiply the L. So let's do it. So I have 9 and 12. So 9 and 12, and I'm going to go over here. I know that my factors of 9 are 1, 3, and 9. And I know that 3 can divide 9 and 12. So 9 divided by 3 is 3. 12 divided by 3 is 4. So I get 3 and 4. The only common factor between those is 1. So then I can pull these out. And then I'm going to multiply my L. So here I have 3 times 3 times 4. 3 times 3 is 9 times 4. 9 times 4 is 36. So the LCM of 9 and 12 is 36. All right, let's go ahead and try this problem that has 3 again. So again, I can only do 2 at a time, so I have 3 and 4, so I put 3 and 4 in the L. Well, I saw over here the only factor they have in common is 1, so I'm going to go ahead and use the 1 and pull those out, and then I'm going to multiply. I know that 3 times 4 is 12, so I'm going to use 12 and 16 in my next one. So I have 12 and 16. Both of these are divisible by 2. So I know that 16 divided by 2 is 8. 12 divided by 2 is 6. So I get 8 and 6. Again, both of these are divisible by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. So I get 4 and 3. And even though they're in a different order, still only going to have that common factor of 1. So I have 4 and 3 that I pull out, and then I'm going to multiply my L. Come off to the side, 2 times 2 times 4 times 3. So 2 times 2 is 4. Okay, and then I have 4 times 4 is 16. Or again, if I want to make it a little bit easier on myself, I can do, because I know my 12s times tables really well, I can do 4 times 3 is 12. And then multiply that by the 4, and I get 48. So the LCM of 3, 4, and 16 is 48. So when would I use this? Let's take a look at this problem for Clint, who is training for a biathlon, and we want to know on what days will he both swim and bicycle. All right, so let's take a look at the problem itself. We know Clint is training for a biathlon. He will swim every 6th day and bicycle every 8th day. So if I want to know which days he's going to do both, I probably need to know that he's going to swim every 6th day. And then I'm going to use a different color because it's a different activity. And I like to do that. That helps me keep my information sorted. And I know every 8th day he's going to bicycle. Okay, so what that means is if I were to pull up a number chart here, now it's not saying that he's only training for a month. It's just saying on what days will he do both. So we're just going to look at the first 100 days of his training, because if you're going to do a biathlon, you're going to train for more than a month. So what this means is every 6th day, so I'm going to go back to my black pen, every 6th day he's going to swim. So on day 6, he swims. Another 6 days, which is day 12 of his training, he swims. Another 6 days, which is day 18, he swims. Notice all these numbers that I'm circling, they're the multiples of 6. All right? Same thing now with bicycling. So now every 8th day he's going to bicycle. So on day 8 he bicycles. On day 16. Oh, look at that. On day 24 I have it circled as a swim day, and I also have it circled as a bicycle day. So I know that on day 24, he's going to do both. And then on day 32, he bicycles, on day 40, and on day 48. All right. Again, we're listing all of these multiples. So if you look here at our numbers, so I have on day 6, day 12, day 18, 24, he's swimming. And then I have on days 8, 16, 24, 32, 40, 48, he's bicycling. So the first day that he does both is on the 24th day. And if you notice, that's actually the LCM. Now, because of the fact that the first day that this happens is on the 24th day, that means that it's only going to happen every 24 days. So if I look at the 24th day and add 24 more days, I get 48. So the 48th day should be the next day that both things happen. Well, let's go ahead and take a look. If I list, so I have 24, 30, 36, 48. I'm sorry, 42. Got a little excited. 48. 30 doesn't work. 32, 36, 42, 40, but 48 does. So I know that every 24 days, Clint is going to do both activities. So then I can look here and say, okay, well, that's the 48th day. If I add another 24 days, that's 72. So again, on the 72nd day, he'll do both. And again, I can list the multiples and come up with the same answer. All right, so my answer here, I would want to say the first day that Clint will both swim and bike is the 24th day of training. Okay, it's important to keep in mind that we're talking about days of training. We're not talking about days of the month. He will do so again on the 48th and 72nd days as well. All right. So this is an example of how we would use this when we're talking about days, like when we're looking at our schedule. A lot of times we'll see this getting used when we're talking about like buying stuff for a party. So if you're buying things for like a treat bag and you know, Tootsie Rolls come in packs of 4 and gum comes in packs of 6, and how many do you need to buy so you have the exact same amount of both? Okay, those are going to be instances where you use the LCM. So what you're going to do, I want you to try each of these 6 problems on your own. And when you come back to class, we are going to practice these word problems together.